All right, guys, here's your review for test 3. We will take test 3 next Tuesday. And we'll start with problem number 1. For number 1, what we notice is that we have a dividing of rational expressions. Remember, when you divide, it's the same thing as multiplying by the reciprocal. So we're eventually going to change that operation to multiplication. And we also take the reciprocal of the fraction on the right. Now, before you do that, you want to factor. So in our numerator, we see the z squared minus 9. We factored using z minus 3 and z plus 3. In the denominator, the z squared minus 15z plus 56. We find two numbers where when we multiply them, we get 56. But when we add them, we get negative 15, and that is negative 7 and negative 8. So we factored that denominator of the first fraction using z minus 7 and z minus 8. Now, for the fraction that we took the reciprocal of, this 9z plus 27, we can factor 9. So we factored out that 9, we get z plus 3 in parentheses. Remember, when you factor out the 9, it's the same thing as us dividing by 9. In the numerator, we factored 8. So 8 from that 8z that left us with z, and 8 from the minus 56 that left us with minus 7. So then we want to simplify that, right? So we took that 9z plus 27, we moved that to the denominator. When it comes time for us to simplify, we want to cancel out any like terms. The z plus 3s can cancel, and the z minus 7 can cancel. So we're left in the numerator with 8 times z minus 3, and the denominator 9 times z minus 8. This is our answer. For number 2, you're adding these expressions, but remember, before you can add expressions, you have to get the least common multiple, that common denominator. So between 7 and 3, that common denominator would be 21. That means we have to multiply the second fraction by 7 in order to make this a 21. We have to multiply the top and bottom by 7. To make the 7 a 21 on the right, we have to multiply the top and the bottom by 3, right? And then we look at our x coordinates. We have x squared and x cubed. So I can make this x squared over here become an x cubed if I multiply it times x. But remember, you must also multiply the numerator times x. The same thing with w's. I have w squared and w cubed. I can make this w squared become w cubed if I multiply it times w. So I must also multiply the numerator by w. So that's negative 7 times 3xw in the numerator. All right, we keep that denominator the same. So see, we keep the 21x cubed, w cubed the same. And when we distribute 3xw times negative 7, you see we get negative 21xw. And then 7 times 4, we get 28. So we keep the denominator the same, and then we're going to add those two terms in the numerator. Negative 21xw plus 28. This is going to be your answer. For number 3, we're evaluating these radicals. So remember, the square root of 4 over 16, that's equivalent to the square root of 4 over the square root of 16. And both of these are perfect square numbers. So the square root of 4, we get 2. The square root of 16, we get 4. But 2/4 can be reduced to 1/2. And for letter B, we have negative outside, so we have to carry down that negative symbol. And the cubed root of 1, that cubed root of 1 is going to be 1. So our answer would be negative 1. For letter C, we have the square root of negative 16 squared. When we take that negative 16 squared, we get 256. So that negative 16 squared gives us 256. But the square root of 256 gives us 16. This is our answer. Now for number 4, we're using radical notation first. So when we write this in radical notation, remember your denominator, that 3 becomes the index. And the numerator, the 2, becomes the power. The base of your exponent, that goes inside or underneath your radical. So it's the cubed root of 8. The cubed root of 8 gives us 2. And then 2 squared, we get 4. That's our answer. For number 5, we want to simplify and assume that all the variables present are positive. So this 12 is not a perfect square, but we could simplify 12 underneath that radical using 4 times 3. We would carry down the s, we would carry down the w squared. And I'm going to circle that w squared and circle the 4 because both of those we could take the square root of them. The square root of 4 is 2. The square root of w squared, remember you're just going to divide that by 2, will give us w. And then we keep the 3s underneath. So our answer would be 2w times the square root of 3s. This is our answer. For number 6, we're multiplying. We're taking the product and then the quotient for that second one. Product, we're multiplying these two inner terms. So 2 times 32, that gives us 64, and the square root of 64 is 8. So this is our answer. For letter B, the cubed root of 81 over 3, we can rewrite this as a fraction. 81 divided by 3 gives us 27, and 27 is a perfect cube number. The cubed root of 27 is 3. This is our answer. For number 7, we're multiplying. So we see the square root of x plus square root 3 squared. You first want to expand that. When we square that expression, we multiply it times itself. So we got to distribute. Square root x times square root x, that gives us the square root of x squared. And then square root x times the square root 3, that gives us square root x times square root 3. In the middle, we have another square root x times square root 3. That's another square root x times square root 3. And then the last two terms, square root 3 times square root 3, right? The square root of 3 times the square root of 3, that gives us the square root of 9. But what is the square root of 9? That gives us 3 on the end. Now these two inner terms, square root of 3x and square root of 3x, that'll be 2 square root 3x. So those two inside 3 and x, we multiply them to get 3x, but we have 2 of them. So that's 2 square root 3x for the 2 middle terms, these two. And then square root x times square root x, that's the square root of x squared. And the square root of x squared is just x. So see, our answer will get, remember you're just dividing this by 2 here. So x plus 2 square root 3x plus 3 is our answer. For letter B, we're distributing again square root x times square root x. That gives us the square root of x squared. Now square root x times that 3 square root 5, that'll give us 3 times the square root of 5x. Right, we're taking that square root x times 3 and square root 5. And then we have a minus 3 square root 5 times that square root x. That'll give us a negative term. And then on the end, we see negative 3 times that 3 square root 5s. All right, so the way we want to interpret both of those, we see square root x times square root x, that's square root x squared, but we know that simplifies to x. And then the square root x times that 3, that will give us a positive 3 square root 5x. And then the two inner terms, negative 3 square root 5x. And then the last terms, we see a minus 3 times 3, that'll be 9 times the square root of 5 and 5, that's the square root of 25. Now, this square root of 25, that becomes 5. You multiply the 5 times that minus 9 in front. So that gives us negative 45 right here. Negative 45. And these two inner terms are going to cancel out. X squared, when we take that square root of x squared, that just gives us x. So see, our answer is X. These two middle terms canceled out minus the 45. This is our answer. And then the last problem, letter A and B, you got to rationalize that denominator. So we got to get rid of these radicals in our denominators. For the first problem, 2 over square root 3, we got to multiply the numerator and the denominator by the square root of 3. So remember, you're going to multiply that numerator and denominator by square root 3. So 2 times square root 3 in our numerator. And in the denominator, square root 3 times square root 3 gives us square root 9. But the square root of 9 is 3. So our answer would be 2 square root 3 over 3. In the denominator, to get rid of this plus square root 3 in the denominator, we have to multiply by that inverse, which is 1 minus square root 3. And that means we're going to have to distribute in this denominator. So 1 times 1, we get 1 squared. Square root 3 times square root 3. Remember, that's just the square root of 9. We know the square root of 9 gives us our positive 3, okay? Well, in this case, that minus is in front of it. We have to carry that down. And then the inner and outer terms are going to cancel out again because we have a minus square root 3 and a positive square root 3. Those two terms are going to cancel each other out. So that leaves us with just 1 minus 3 in the denominator, or negative 2. And in our numerator, we just distribute that 1 times 2, that gives us 2. And then 2 times that square root 3, that gives us a minus 2 square root 3. Okay. So here we are with our final answer, and let's be prepared for test 3. Good luck on the exam.